the steps, then there is not going to be any problem. Okay, I'm back to sharing. So let's choose at least one more, or maybe two.
Can we do 65?
Yes, 65. So limit in 65, let me copy it. 4x plus 1 raised to cotangent x. And what is it? X approaches 0 from the right. Good, perfect. Okay, our starting point. Anyone?
We're going to do the bring cotan x down with ln.
First we have, yes, but I have to name the function. But first I have to identify what this is. Maybe this answer is 2 squared, and I'm done. I'm not going to start doing anything before I check the type of indeterminate case.
So we're going to plug in 0.
Yep, so this goes to 1. Maybe this one doesn't. Maybe this one goes to 5. So I have to test. So cotangent when x approaches 0. Remember, cotangent x, it's cosine over sine. So when x approaches 0, unfortunately, this approaches 0 from the right, and this approaches 1. So 1 over 0 from the right is like 1 over x, so this approaches infinity. So we're back to the same situation, 1 to infinity. Same one. Okay. Good. So now in first step, I know the type of indeterminate case. So in the first step, I have to name the function. So this is it. This is a mandatory first step. In step 2, yes, I apply natural log. And cotangent goes in front because I'm lazy, I don't want to write it twice. Now in step 3, what do I have to do in step 3? Anyone? 10, I haven't heard from you today. Okay, anyone else?
You add the limit?
Yes, we apply the limit as x approaches 0 from the right, from natural log y equals limit. Oh, I didn't mean that. Cotangent x times natural log 4x plus 1, of course, when x approaches 0 from the right. Okay, perfect. So now we have to see what this limit is all about. That's our next step. That's our focus right now. Get this limit. So then we can copy the beginning and the end. Good. So where is this going? And where is this going? And you can say, you already told us, this goes to infinity. And the natural log of 1, because this is 0 plus 1, we know that this goes to 0. By simply applying the limit to the natural log of the function, I reduced the power 1 to infinity. I reduced it to 0 times infinity. Nice. Much nicer. Because now I only need what? To get this limit. I only need, what do I need? What did we say we need for the case of a product?
Algebraic manipulation.
Excellent. So do not attempt to take the natural log anywhere. It would be a tragedy to move it down somehow to power -1. No. I'm going to have to work on this piece. So I'm gonna change and go here. Okay, so then I have limit as x approaches 0 from the right. I will keep natural log at the top. And I like to flip cotangent, but I know cotangent is 1 over tangent, right? So I know that cotangent x equals 1 over tangent x. So I will replace this by 1 over tangent. And now this is, again, music to my ears, because the top goes where and the bottom goes where. Where does the...
0?
Yes, awesome. Exactly. So from now on, it's a piece of cake. So I have limit as x approaches 0 from the right. The numerator is 1 over 4x plus 1 multiplied by 4, and the denominator is secant squared. So now we attempt again and see what this gives. Where does the top go?
Just 4.
Yes, awesome. It's 4, right? When x approaches 0, this is 4 over 1, so the top goes to 4. Right? It's 4 over 1. And where does the denominator go? Where does secant go when x approaches 0? It's 1 over cosine. Very good. So this is 4. Final step, step number 4. I copy the beginning. This is my beginning. And this is my end. So I copy limit as x approaches 0 from the right from natural log y equals 4. Yes, all these functions are continuous. And what will I do next? To determine the limit as x approaches 0 from the right of, and now I can put the function in, 4x plus 1 raised to cotangent x. What will that equal to?
E to the power 4.
E to power 4. I swap the operators, and I can write it again here. So this is natural log of the limit of y as x approaches 0 from the right. E to power 4 equals this, which is this. Very good. So that's how we deal with powers, indeterminate cases like 1 to infinity. I'm going to share my screen. I think we should choose another and then give it a rest for a while anyway. So let's try 68, because I like to have at least one more power. 68, limit as x approaches 0 from cosine x raised to 1 over x squared. Good. How do we start? What is the first step?
Plug it in.
Yes, we have to. Good. So let's see, where does this go and where does this go? To identify one of the 7 indeterminate cases or none. And then the answer is 15 or something.
Cosine goes to 1 and then 1 over x squared, is that positive?
Exactly. Because the graph of 1 over x is this, but the graph of 1 over x squared is this. Absolutely. So now we have a different All the other ones, I thought we're gonna get 0 to infinity or something, but I didn't hit it. So we can do another, that's fine. So the first step again is y equals cosine x raised to 1 over x squared. Of course, step number 2 is natural log y, which is 1 over x squared times natural log of cosine x. And again, we apply limit to both sides in step 3. So limit of natural log y as x approaches 0 equals limit as x approaches 0 natural log of cosine x over x squared. Music to my ears, this is 1, natural log 0 over 0, I love it. So this is limit as x approaches 0, natural log 1 over cosine x times the inner function prime over 2x. So cosine, when x approaches 0, cosine will go to 1. If you remember, sine x over x, when x approaches 0, where does this go?
Does that go to 1 as well?
To 1, very good. So this is 1, this is 1, there is a 2, and there is a minus. So what is the answer?
Negative 1/2.
Good. So now in step 4, I write that the limit of natural log y as x approaches 0 equals negative 1/2, but I'm really interested in the limit as x approaches 0 from cosine x to 1 over x squared, and what will that be? Cosine x raised to 1 over x squared. What will that equal to? After I swap the operators.
E to the negative 1.
E to negative 1/2, or 1 over the square root of e. Very good. Did we get the idea? Do you think we need another? I just couldn't, I can't see an example in which infinity, so what is this one? This is infinity to 0. Okay, we can do this one. This will be another one of another power. Let me see what this one is. Infinity to negative infinity. So that's not an indeterminate case. So yes, let's look at 63 and then move on. Is that okay with everyone?